Hello, I like to discuss the role of blockchain technologies in digital assessment at the EduLearn 2020 virtual conference. My colleagues are Simone Kriegelstein from the Austrian Institute of Technology and University of Vienna, Steven Bezzina from the Ministry for Education and Employment in Malta, and Thomas Wernbacher from Donau-Universität Krems. My name is Alexander Pfeiffer. I'm a postdoc at MIT, the Comparative Media Studies Department. I'm still associated with Donau-Universität Krems. I was the head of the Center for Applied Game Studies there for 9 years. I'm co-founder of the Picapipe GmbH in Austria. We recently won the Austrian Blockchain Award in the category research. I'm doing my second PhD at the University of Malta at the Department of AI. I've been a blockchain consultant to the Malta Information Technology Agency with the company that I co-founded with Steven, which is the Emerging Technology Consultancy Lab. My project at MIT is called Blockchain Technologies and Their Impact on Game-Based Education and Learning Assessment. And based on this project, my colleagues and I tried to write this paper for the EduLearn 20 conference. So what is blockchain and why do we use blockchain? Blockchain in best case, of course, there are many fraudulent examples that would be a talk on its own, but blockchain in best case stands for objectivity, security, trust, reliability, transparency while keeping the privacy intact, ownership of the data, automatization processes through smart contracts. So in best case, this is the reason why we work with blockchain technologies to design the future of digital assessment. There's this terminology called DLT, distributed ledger technologies, and blockchain is part of the DLTs, but not all DLTs are blockchains. So what is the difference? For blockchain, transactions are grouped into blocks, and the blocks are cryptographically connected with each other. So what does this mean? After a certain period of time, after a certain file size, all those transactions are basically sticked together, put into a block, put as a block on the ledger. And this is the difference to like the general term DLT. So really important is the hash function in regards to blockchain technology. And the hash function is an image that maps a larger input quantity to a smaller target size. So you have text, you have certain other information like the timestamp, maybe other data like geolocation, etc. And all that derives to the unique hash. There's also a function called that you can sort the hash. So basically some random numbers are added that the hash is at the end really a unique number. How does a blockchain now work? It's a very simple example. We have the Genesis block, the first block created. We have some data in it. As said before, because of the data and like a random number that is the sorted, which I explained before, this creates a hash. And then after, let's say, a certain period of time, the block is closed and put on blockchain, which means that all the computers that are connected with each other verify that the data in the block is correct and that they store the block. And then the next block is being created, and they are connected with each other like with glue with the hash function. So this is the hash function of block 1, and you see it that the second block starts with exactly the same hash function. The data in the second block creates a new hash function, and then the third block is being created. So block by block is stick to each other, cryptographically connected with each other with the hash function. There are several platforms where you can have a look into blockchains. They're so-called block explorers. For example, blockchain.com, where you can look into the recent transactions of Bitcoin, Ethereum, and other blockchains. If you use such platforms, you have to keep always in mind that a third party is delivering the data. So although we kind of trust blockchain.com to give us the right data, of course someone can manipulate the data. So if you really want to see the information knowing that nothing has been manipulated, you have to run your own node, meaning that you run your own copy of the blockchain, which would be, for example, a Raspberry Pi, and the Bitcoin blockchain at the moment is like 300 gigabyte of size. In comparison, other blockchain is another system is 500 megabyte of size. So it really depends on the different blockchain systems, but you can still store it on a Raspberry Pi with a data card in it, and then you can keep your very own copy of the blockchain. At blockchain.mit.edu, you can demo for yourself what I've shown you before, and you can kind of simulate how such a blockchain works. Blockchains can be public, consortium-based, or private. Public means that you can run your own node and you can have access to the data. Consortium-based means that a certain consortium runs a version of the blockchain, so it's not accessible by everyone, but only those who are registered or working with the consortium. For example, if banks like to work with each other, they maybe don't really trust each other 100%, so they decided to run a blockchain so that each bank knows that the data is representing the truth, for example, of the bank accounts. And the private blockchain would be, for example, if just one company runs a blockchain between their departments. So that's really kind of a private solution for one entity. Those blockchains can be run permission and permissionless, meaning that, again, you can give everyone in the consortium access, or some people can really write data in the blockchain while others just have the permission to look into the data. And of course, private and public blockchains can work kind of together. So basically, if you decide to use a private blockchain for, let's say, the GDPR compliant data, but then every 2 hours you send a hash of the transaction that occurred the last 2 hours onto a public blockchain. So every 2 hours you have the possibility, if someone takes a look into your data, you can prove that you did not alter the data in the past. There are different types of tokens and there is no common wording. So basically I try to do such a wording for this talk myself, because digital tokens can be cryptocurrencies. So basically the main purpose is more for monetary, representing monetary value, like for Bitcoin and Litecoin. Then we have tradable network maintenance utility tokens. This would be Ethereum, basically. So on the one hand, they have, of course, monetary value, but on the other hand, you need Ethereum for sending transactions. So you pay gas to the network that the computers verify the transactions. And then we have the utility tokens. And utility tokens are tokens that have a certain purpose. In our case, a utility token represents a grade, represents a learning certificate. But a tradable utility token in a game could be the in-game currency, for example. And here I make a difference between, or we make a difference between the non-tradable utility tokens, which I outlined here in green, because this is the type of tokens I used to work with. So we make sure that those tokens cannot be peer-to-peer traded with each other. So basically, if a student has a blockchain wallet, so this is a unique address where you store the tokens, and you send a token with the grade on it to that particular address, you have to be sure that this information cannot be manipulated, and you have to be sure that this information cannot be sent to another address. And then we have tradable utility tokens. So those are utility tokens that can be sent from one account to another, and that might be even utility tokens that can be sent to an account and sold versus another type of cryptocurrency or regular fiat money like a US dollar or euro. You have a list of all cryptocurrencies and tokens that are traded versus cash or versus another cryptocurrency on coinmarketcap.com. You can play around with that website, and there you can also select, for example, that you only see those networks where another type of token can be created on it, so a utility token, for example, or if you like to have the full list of all cryptocurrencies that are currently available on the cryptocurrencies exchanges. If you'd like to trade yourself, please be very careful and do the best research that you can. An important thing for blockchain, if you use it beyond the usage of cryptocurrencies, are smart contracts or lightweight smart contracts. Smart contracts, we speak about contracts, digital contracts, where you can be fully creative and you need to program the smart contract and you can basically create everything you like. And lightweight smart contracts are based on a basic set of functions, so you cannot be 100% creative, so to say, but I guess that 80% of the use cases you can imagine with blockchain can be conducted using lightweight smart contracts. So I always use this example with clay and Lego. Smart contracts, you can do something perfectly working for years between partners worldwide, or you mess it up and then, for example, funds are blocked or even stolen. So when you read in the newspaper that, for example, I don't know, 200 Ethereum has been stolen, it's not stolen from the blockchain itself, it's stolen from a smart contract that works on the blockchain, which has a malfunction. For lightweight smart contracts, it's like Lego, so you can play around with the blocks, but you can't really create something that can be used for fraudulent, or that can be, for example, hacked or has a malfunction. Because during the building process, you would see that this is not allowed and not working. Now, some general examples to explain blockchain technology. You use it when a middleman is usually needed. So you use the smart contract or blockchain technology that instead of the classic middleman, for example, a bank in between banks, the smart contracts is performing that role. So one example that I really like is that if we have smart contracts in our cars and then we have a parking space and then the car parks in the parking space and you allow your car to pay for the fine, you pay like for the fee for the parking space, and then in 99% of the cases your wallet is funded or your bank account, the car pays the fees, everything is fine. But imagine that your wallet is not funded, and then the smart contract could basically say, okay, I as the provider of the parking space did not receive the money, so I'm allowed to block the engine. And then only if you finally pay for the parking fee, you can use your car. So this would be a quite good example for such a smart contract. Voting is a really good example. If you combine digital identities with voting on blockchain, there would not be the need to actually go to vote or to use letter-based voting. I suggest for the beginning that we combine both systems. You vote digitally, but you still go to a school. And but voting is a really powerful tool. Voting combined with digital identities, that's something blockchain is truly useful. In logistics, basically to track the items shipped and even to prevent the items shipped to be frauded on the way. So basically you can do both sides. You can seal the packages using chips and blockchain-based data, and you can track those packages while they are en route. The difference to how it's done at the moment is that we're not using a centralized database. So in this case, the logistic company cannot rewrite the information where the packages have been. As it is stored on blockchain, it's impossible to manipulate the data. Another example, because it just comes to my mind, is, for example, I was riding a taxi in Malta, and then there was a car accident, and I saw that the taxi driver was riding the car with 90 miles per hour. And then I complained that the car driver was driving too fast. And then I received an Excel sheet from the taxi company. They said, no, our drivers, they are tracked with GPS. They were not running too fast. So if it would have been on blockchain and every 20, 30 seconds, the speed would be tracked on blockchain, there would be the entry with the 90 miles per hour. And there would be no way to manipulate it. But as the information, how fast the taxi was going, comes from the taxi company as an Excel sheet, you download the Excel sheet, you delete the 90, you enter 50, and you send it to the customer and say, no, 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 our cars did not run too fast. Music. So basically you play music, you write a song, the song is played on the radio, and using smart contracts, the share of the revenue of the song can be split between the band and the publisher, between each single member of the band, basically in real time. In esports and betting on esports, blockchain technologies, for example, using the platform HeroCoin, made it possible that you can basically peer-to-peer bet against one of your players you play with, and you decide to go for betting who is better. Land registry on blockchain, something that Malta is currently working on, because they have this big issue that you really don't know at the moment for some houses to whom they belong. So it's quite difficult, and that's why they try to completely rebuild their land registry system. The last will, so of course you can still use a notary, but the last will is based on blockchain, on a smart contract, and then everyone who is in the last will meets at the notary. The notary just needs to press one button, everyone signs digitally that they agree, and then the last will is being passed on to the people that get their share of the last will. So it will not take months, it can be handled basically within hours. Then we have, for example, the production of power through, for example, solar power. And then within communities, the producer, like the owner of this household, could actually resell overproduced energy to the neighbors, or can resell overproduced energy to the network grid. With blockchain, this would be possible to do it directly with the neighbors, and then the energy provider or the government, etc., gets like a file each month that they see that everything is correct and lawful. Digital items on blockchain. So you can, here's an example from Minecraft, that some items on Minecraft can be now put on blockchain, so you can really create unique items. Then we have tradable goods, and the most famous one is CryptoKitties. Those are a unique graphic of a kitty. You have to breed kitties, so two kitties meet and breed a new kitty. For each step you take in the play in this collectible game, you need again gas, or you need Ethereum as a currency to create such kitties and to trade them. And it's already working for years. And CryptoKitty is a really good example for collectibles and for art on blockchain. Art, you can secure real items on blockchain, so you can issue the ownership certificate on blockchain, and then if you like to sell a picture or put it into an auction house, then you need, of course, the real picture, and you need the ownership signed by you and signed, for example, digitally by a notary or by an auction house or whatever. And then it has to be clear that only the owner of the digital asset representing the picture, the painting, is the real owner of the painting itself. Social networks is something coming and going with blockchain. The most famous one is Steam. So basically, when you get a like or when you write something, you have the possibility to earn Steam as a cryptocurrency, which is freely traded. In 2017, Donau University made a test, so to say, a small research project. So we blogged on Steam, and our goal was that after 3 months or 2 months, all the Steams that we got from writing the articles, we invested into tablet PCs, and we sent them to a school in Tyrol, but not Tyrol in Austria, but Tyrol in Brazil. And the kids, they were really happy. It was the first tablets ever that this poor school had in Brazil. Tickets are brilliant to be represented on blockchain, especially if you, for example, like to sell the tickets to a third party, or if the owner changes. So that is something that if you use blockchain technology for the ticket sales, that you can totally, it would be possible to totally get rid of the black market sales of such tickets. And as I said before, what's really important is, and what's unfortunately done quite rarely for utility tokens, so for trading and for speculation, of course, connecting your wallet with identity is one of the most important parts. It's for the anti-money laundering laws, AML and KYC, know your customer. So the banks, the traders know who you are. But for the utility tokens, it's rarely made. And I think it's of utmost importance to connect digital identities with blockchain assets. And this would give us the possibility, for example, to store learning credentials connected with the ID wallet of the person, access to municipal services, your health data, your tickets, and then you can actually combine all of this data with a certain identity that you choose, for example, your citizenship card, your Facebook login, whatever identity you choose, and whatever identity is capable of performing the identity test, so to say, or the level of identity you need to provide to combine it with such token when you, for example, prove that you are a member of the school, or prove that you're the owner of a ticket. Such systems need to be capable of processing on different blockchain systems. And I think this is the future of how our possessions, most of our data is going to be handled in the near future. Digital agents is also one of the projects I'm working at. This is triggering, and this is also might be important for the educational system in the near future. This is that we assign to our digital agents, to our supporting AI systems, a digital identity, so that when the agent is performing a task on our behalf, we know that the agent was allowed to perform that task on our behalf. So for example, here with look up and paying the tax, our agent looks up if we have to pay the tax, then yes. If it's under 5,000 euro, you give your AI access to pay the tax for you, for example. And all those little steps are stored on blockchain, while for the private data, only you as the owner of the digital identity, and basically at the end of the day, the tax authorities get access with their key. On blockchain itself, for the public, only the transaction hash is being stored, and they don't know which kind of data is in it. So let's now have finally a look on the impact of blockchain technologies for assessment. And my MIT project was, or is, triggering 3 different parts. One is game-based learning and assessment, e-learning and assessment, and in-person and online conducted oral exams. And with my colleagues, with Stephen, Simone, and Thomas, we then took a closer look onto this part, and we performed an online research. The online research is about the perception of blockchain in the educational sector. This is what you can read in the paper, but now I like to show you a little bit more about my work, as I see this talk actually as an addition to the paper. So the project I'm currently doing, or just actually finished right now regarding that prototype, is a game called Gallery Defender. It's a game about art for the age group of K-12. And you register with your unique Aadhaar address, click on Verify Account, or you can use the test account that we provided. Then you have a tutorial level, you can practice, you can simulate the exam, or you click on Assessment. If you click on Assessment, then it says, hey, this is an assessment. You only have 3 trials to pass this exam. We also implemented like a test screen where you can send all those tokens and see the magic, so to say, without actually playing the game. So here you see this score from this level will be recorded. You only have the 3 trials. So then you play the game. It's about art, so you have to assign art styles, and you're the owner of a gallery. You play versus the thief. And then at the end, so for example here, after 330 seconds, you get a grade, and this was an A. And now we come to the blockchain part. So basically, here we are logged in as the pupil. We just passed the exam. We use our private key. And then we get the encrypted message, which represents exactly the outcome from the game. So we have 1 token. For the game, we created like 10 million tokens of one type, which represents the grades for the pupils. So 10 million pupils or students can perform the test. And the main wallet address from the game sends 1 token with an encrypted message attached to the student account. And with a function called phasing, we make sure that the student is not capable of sending the token to another person. So if you, as a student now, decrypt your message, you get a shared key. This shared key can you can give to another person to encrypt that particular message, but this person will not get access to your whole account, only to that particular message. As this is kind of a lifelong shared key, and this is for everyone, the next step we are doing is that we design a platform where the shared key is then creating temporary keys, so that you can give access to a particular set of data to a person for, let's say, 2 days. So the another function that we already implemented is that you can use the shared key and send it, for example, in an email and an internet address to your boss or to your future boss, or when you apply for a job. And this is basically that the future boss gets the information stored on blockchain, signed by the issuing institutions, signed by the teacher, that this is the certificate issued, or in this case, just 1 single grade. So we created a token for the learner, token for the teacher, a gamification part. If you performed an A or B, you were able to redeem it for a particular item. And the verification tokens and the approval model. So as I said before, to secure that these tokens cannot be traded. So the second part was the Gallery Defender quiz. This was produced by Austrian company where I'm a co-founder, Picapipe GmbH, also during my MIT project. And we use this as another design for the token economy. And instead of game-based learning, it's e-learning. So it's a simple quiz that you can take on the topic of art. First you start, and it's also a web app. So first you start with insert your address, then you take the quiz. You have the points at the end. And here we tried something different. Instead of creating 10 million tokens where you attach the message sent to the student, every single grade is a singleton asset, a unique asset on its own. So when you pass the exam, here you see it from the 1st of October, and we asked the network to create this unique asset. Then in the account properties, and not as an attached message, the grade is stored, and then the token is sent to the student. Here, and this is based on a smart contract. It's a bit more complex than the first example. And both examples can work for different use cases. So by design, I just wanted to test all that came to my mind, or we as a team tried to test this, and we are quite happy about the different outcomes. Other use cases for blockchain in school would be voting for the schoolboy, elections, scholarship management, a digital class book, the enrollment process, securing the SAT results in the US. As you know, last year there were some fraudulent things going on, competence profiles of pupils and students. So what's really important, again, is identity. So we have to make sure that we use ledger digital identities. In Europe, it's easy. We have the eIDAS regulation. Most of the countries have their digital identity systems. In Austria, it's, for example, from A-Trust, so nearly 1.5 million Austrians already use citizenship card on the smartphone. But in this case, we just need to link, or we need to sign and link that a teacher is part of a particular school, and then the students, of course, need to have an identity. And in our case, such an identity is issued when you're 18 or older. So we need digital identities, or a set of digital identities, especially for pupils. So this is quite a long way to go, but something that we need. And we link these identities with each other, and then you have this e-identity wallet for the school grades, where you store the part of exams, the certificates, even at the end your graduation diploma. And then with shared keys, you give access to third parties, like your parents or your future boss. Other examples are basically that you can make direct contracts between teachers and learners, for example, for the after-school market when pupils need help. Something like that would be a really good way to teach learners and to have a smart contract where you assign, so for example, it's 10 euros per hour and the contract is for 25 hours and we're meeting every Tuesday at 10 a.m., for example, that you put into a smart contract. And then if you meet in Zoom or in any other software for those 20 times, 25 times, and then every time the learners pay with the wallet to the teacher. There are, of course, solutions on the market like BlockCert, but what BlockCert also from MIT is doing at the end, it's verifying that this is a real document using a so-called one-way hash. So it's not storing the information itself, the grading itself, as I showed you before on blockchain, it's just proving that a document is an original. In oral exams, the third part from the project is that imagine someone has a thesis defensio, all parties involved sign digitally the grade. Then a smart contract pushes this document to the administrative departments and director, everyone signs digitally, and not after 1 month, but maybe after 1 or 2 days, after everyone had a look at it and signed with their digital identity, the student can call him or herself Master of Arts, for example. And then, again, I already talked about this, all these achievements and credentials you have on blockchain can be shared with particular other parties for the particular use case. And this will make verification of data, of achievements, of certificates much, much easier as today, and the proof is more legit, and you don't need to basically employ or to look for and pay companies that are specialized in proving that this document is legit. For example, it's an HR manager, because it's on blockchain, you get the shared key, you see all the digital signatures, and this is extremely helpful. So just at the end, some results from the online survey that you can read in the paper related to this talk. Which steps are necessary before considering using blockchain in education? So we need sophisticated privacy settings. We need basic information provided to all people involved in the educational sector. There needs to be transparent rules who is responsible for the payment of fees, talking about the transaction fees to a public blockchain. The IT professionals and the administrative staff needs in-depth education. So those are quite important parts we need to look into before we even talk about blockchain in the educational sector. The use cases, I already talked about that before, but from the 140 interviewees, which were people working in the educational sector and IT professionals working with blockchain, said that handle payments is like the use case that is, this might be the the first use case you think about talking about blockchain, taking exams, IT checking, and of course the grades at the end of the year and the certificates is something you should use blockchain. But what we see here is that if you separate the IT professionals and the educators, and the scale was from 1 to 7 actually, and you ask them how do they assess their knowledge about blockchain, the educators assess their knowledge far less than the weighted average. So we really need to start, as I tried to do right now, to educate teachers on the topic of blockchain. So if you'd like to contact me, you can do so writing me on Twitter, following me, that would be really nice. Alexander.pfeiffer.uni@cat or alex_pf@mit.edu. At alexpfeiffer.mit.edu, you see my research page. So thank you very much, and it would be lovely if you try to connect with us. Here, just some information. I wrote a blog article how all this research that I did or that the team did regarding blockchain in education could also truly help during the COVID-19 crisis we have been facing recently. So if it's a good read, I think if you look into it, it would be great. Thank you very much and enjoy the virtual eDoLearn 2020.